We are going to learn about substitution reaction in this chapter. But don't feel like this is a new topic for you. You have seen substitution reaction before, and actually in an acid-base reaction, that's chapter 3, right? We call those as acid-base reaction, but it's a type of substitution reaction. If you don't believe me, let me show you. Now, right here, we have an acid, hydroiodic acid, a base, sodium hydroxide. This is a totally acid-base reaction, right? Now, look at what happened. There's a substitution reaction going on here. So first of all, this hydrogen here replace sodium to covalently bonded with hydroxide ion to form water, right? That's a substitution reaction. If I ask you to draw a curved arrow to show how this reaction works, you should be able to do a nucleophile attack on an electrophile, hydrogen right there, and hydrogen does loss of leaving group, right? So leave iodine, okay, and you get the product there, all right? Now, but there are more to it for a substitution reaction. Give you some example, right? It doesn't have to be just a hydrogen in an acid-base reaction. A regular other reaction can do substitution reaction as well, right? And we have ethyl iodide, right? It looks like an ethyl group replaces sodium to bond with oxygen with the hydroxide. You get ethanol there, right? Two carbon and alcohol, ethanol, right? And sodium go ionically bonded with iodide. You get sodium iodide. That. All right, the question is, what's going on in this reaction? How does it occur? We're going to talk about this into the detail, the kinetic aspect of it, the thermodynamic aspect of it, the product, and stereochemistry. All right, enantiomer, diastereomer are going to come back in here. All right, and before we get into the detail, let me take you through what's going on. When did we discover this reaction? When I say we, I mean by human race. When I say human race, I mean by just a couple people who actually studied this, right? All right, I'm going to take you to a tour to Europe. Have you been to Europe before? Some of you have. All right, I'm going to take you to this place. I have to fly from United States and landed into England, specifically in London. Right, London is right there. I'm going to go to London there, right? At the center of this capital of England, there's a large university called University College London, UCL. In the middle, right? Look like this. This college, not college, this university is founded in 1826. Right? The enrollment, look at the number of enrollments, big number compared to United States. That's a very big university, right? Probably close the same size with Indiana University, about 40,000 students. The largest university in United States is either the University of Central Florida in Orlando, 60,000 students, or Arizona State University. It's 1 and 2, depends on the year, right? But think about it: UCL is a capital of London. They don't have much space, and fit 40,000 students into it's still relatively large, but into like relatively small area in London. It's tight, really tight, right? And UCL is the third oldest university in England, behind I'm sure you can guess Oxford. Of course, Oxford is like number 1, the oldest, and Cambridge. Actually, I'm not sure either one. One of them is the older, all right? But it's number 1, number 2. This is the third one, all right? And there are 30 Nobel Prize recipients that graduated from this university. And if you want to go study or maybe study abroad at this university, this is just how much you have to pay. 29,000. I don't even have that money. That's it per year. If you stay there for like 4 or 5 years, oh man, that's like a house. Yeah. All right. Anyway, so a little bit more than that. So let's take a look at some of the notable alumni. So we got Mahatma Gandhi, Alexander Graham Bell, who invented telephone. This is the first version of telephone. That's a mouthpiece. That's an earpiece that you have to hold like that, right? I don't even know how they dial it. Like there's no number there. Anyway, down here, so the famous Watson and Crick DNA structure. So Francis Crick went to UCL, right? And the handsome and young singer of Coldplay, Chris Martin, went there too. He's that smart. I didn't know that. I looked up a little bit. Hey, Chris Martin, he went there. Anyway, so if you don't know what the Coldplay is, so it's one of the rock band. right? Anyway, not like Backstreet Boy, totally different, but they are really really famous. Anyway, so when I go back in time, hold on, okay, move. Okay, in 1930s, even before Chris Martin was born, okay, way before, UCL, at UCL, there were one professor and his postdoctoral. We have Dr. Hughes, just freshly graduated from a PhD program. I'm not sure where he's from. Somewhere, I don't remember. Anyway, so he's doing work after PhD, so they call it postdoctoral, right? So we call it postdoc, and under Professor Christopher Ingo, right? And I'm sure you heard this name before, Khan Ingo Prelog RS system. So Sir Ingo, he did have a lot of touch on that RNS system, okay? But this guy, same one here, right? Anyway, so these two scientists discover a substitution reaction, and they try to try to learn how things work and try to explain it. All right. So they found that if they mix ethyl iodide and sodium hydroxide, they will get substitution product and a salt coming out of the reaction. Of course, they can't explain it the first time they saw it. So yeah, let's find out. They have to go back to the lab, do some more experiment, and see what those experiments can tell them what's going on in here. All right. But at the same time, like the same time, 1930s, not only these two who study the substitution reaction, there are a lot of scientists, and it's like a race who can study, who can discover, who can explain how it works first. They can publish it, and you get a fame, and you get money, the grants and fund. Okay. All right. But so these are other mechanisms that they propose, and let's see if it makes sense to you. One possibility in saying that how the substitution reaction works. So we have a nucleophile, attack, and electrophile. Right? Attack right there, and to form pentavalent carbon intermediate. You probably have think it right now like, dude, this doesn't make any sense. There are like 10 electron carbon. What is going on here? Of course, it doesn't make sense, and it got rejected later. Right? But let's take a look at the whole thing. So after this, iodide leaves, and you get the substitution product, right? Ethanol. Or another possibility, so iodine leaves first to form a carbocation intermediate. What type of carbocation is this? Primary, secondary, tertiary. This is primary. I'm not sure if you remember, primary is one of the worst carbocation, with a very highly unstable, right? And we have hydroxide ion attack, you get an ethanol. Or these two steps happen at the same time, in the same step. Okay, these are like the three main possibilities. There are others too, but I just want to show you. But we're gonna do some more experiment and look back to see what does those experiments tell you, which one or maybe some other type of mechanism makes sense. All right, let's moving on to the next